Okay, so in this video we are going to use normal approximation to Wilcoxon rank sum test. So in the last video we calculated the test statistic, which is rank sum of population 1, and it was equal to 20. Now this test statistic, it's only depend on the sample size, and it's not depend on any depend on shape of the population. So it's not depend on population shape of population. It's not depend on shape of population. So the idea is, if samples are large enough, then the test statistic itself is normal distributed, even though populations are not. So if n1 is more than 10, that's the condition, and n2 is more than 10, then the test statistic is normal distributed with some mean and variance. Now this mean and variance, they are, you can calculate actually. The mean is given by n1 time n1 plus n2 plus 1 divided by 2, and the variance you can calculate too. It's given by n1 time n2 n1 plus n2 plus 1, everything divided by 12. So now this is nice. Even though populations are not look like normal, the test statistic itself is normal. Now in the last video, the test statistic is not associated with any distribution, but now this one is associated with normal distribution. So you can use this to calculate p-values, test statistics, critical values. Now in last video, if you look at those tables again, you can use only alpha equal maybe 0.025 or alpha equal 0.05. But let's say you want to use alpha equal 0.1 or 0.03, then it's not possible to use those, because the table does not provide the critical values. So you have to stick with one of these values, 0.025 or 0.05. But when you use normal approximation, you can use any kind of significance level, and you can easily calculate critical value, and you can come up with the conclusion. So so let's write down our hypothesis again. So my H naught is mu men minus mu women is 0. HA is mu men is more than mu women. Now let's say my alpha is 0.03. Okay. So what do I do? I'm going to use this distribution now. So I have test statistic is normal distributed. Okay. So now I need this side alpha, because it's left right tail test. This is right tail test. Okay. So alpha equal 0.03, and I need the critical value. So how do you calculate this critical value? So this is basically what? It's basically inverse norm if you are using TI 8384. Area to the left, that is 0.93 and 97, and then mu and sigma. Okay. So what is mu? Mu is going to be, we haven't calculated this. This is going to be 4 times, if I use that formula, 4 plus 4 plus 1 divided by 2. This is going to be what? 8, 8, 1 plus 9, 9 plus 2, 18. And then the sigma, variance is going to be 4 times 4 divided by 12 times 4 plus 1. So 9 plus 4, 36, divided by 12, 3 is 12. So this means sigma is the square root of 12. So now I can calculate the this critical value. So here I have alpha equal 0.03, and then this critical value, that's basically inverse norm 0.97 18, that's mean, and square root of 12. This will give me, I'm going to use my calculator. So it will give me, let me see, 0.97, mean is 18, and sigma is square root of 12, and I get 24.55, 51526. Okay. So now our test statistic is what? My test statistic is 20. So it's somewhere here. It's not that critical region. This is my critical region. So since test statistic is not in critical region, we fail to reject H naught. So that's the conclusion. Now in this example, actually sample sizes are not more than 10. I just used this example just to show you how to use normal approximation.